In section 1, we were able to explore the 4 different conic sections that we have and just kind of see some general characteristics about each of them. The rest of our chapter breaks down each conic section a little bit more. In section 2 of chapter 10, we are looking specifically at parabolas. Throughout the year, especially first semester, we worked quite a bit with parabolas and we learned the different forms that we could write their equations. We learned that they're symmetric, a lot of different things about them. And just kind of, as a recap, here's my parabola. And parabolas, our parent function is y equals x squared. I'm going to write y equals ax squared as my go-to function for my parabola here. Y equals ax squared. A, that tells us our vertical stretch. Now, we learned what a parabola looks like, and we learned the different forms for it, but we never really came up with a good definition of what a parabola is. So here's my definition of a parabola. A parabola is all points that are equidistant. If you remember from geometry, equidistant, all points that are the same distance from a specific point and that specific point when we're talking about parabolas is called the focus. And a specific line. And that line is called the directrix. Okay, say that again. Parabola is all of our points that are equidistant from a specific point, which is the focus, and a specific line, a directrix. So looking at my diagram of my parabola here, inside my parabola, somewhere inside my parabola, I'd have an inside point. That point is called the focus. And I would also have an imaginary line out here called the directrix. All points on my parabola are the same distance from the focus and from the directrix. And I have a little animation here that I will go to show you. If I can get out here, there we go. So again, here's my parabola. This purple point here is my focus, and then this, I don't know if that's blue or green, that line is the directrix. So all of my points on my parabola, this length and this length are the same. It doesn't matter where we are on a parabola. We could be at the vertex of the parabola. The distance from the vertex to the focus and the vertex to the directrix are the same. Even if I zoom way out on my parabola and I go way up here, the distance from my focus to this point on my parabola and the distance from that point to the directrix are the same. Okay, so that's our definition of a parabola. Now, our equation for our parabola, y equals ax squared, we also could use the equation y equals 1 over 4p times x squared. Where p is what we call the focal length. Okay. And I'll show on my diagram what that focal length is. So a couple things here. Here's my focus. This line is our directrix. And then right here, the distance from my focus to my vertex is the focal length. The focal length P. Now, since this distance from my focus to my vertex is the same as the distance from the vertex to the directrix, we also could say that distance is P. Depending on what information we're given, sometimes that's a little bit more helpful. All right, let's get all the new information out of the way, and then we'll get into some examples. So all of the parabolas that we've seen have opened either upward or downward, but we also can have sideways parabolas. And our sideways parabolas are pretty similar. The biggest difference is that if we have a sideways parabola, it's not a function. But even in our sideways parabolas, we have that focus. Our distance from the focus to the vertex is our focal length P. And we also have our directrix here. Okay, our sideways parabolas, instead of being y equals ax squared, look like this. X equals ay squared, or x equals 1 over 4p y squared if you're using that second option for your equation. Okay, that's all of the information. I'll keep all of the information in this one video, and then our next videos we'll get into some examples.